Today we're going to talk about a really interesting paper I read recently, which investigated how drugs that you might take, everyday drugs for medical drugs, of course, for different health conditions, how they might be affecting your health in another way by having a potential impact on your microbiome. It's well known that drugs can affect your microbiome, but it's not very well understood as to what that might entail in terms of your overall health. And the authors of this paper did really interesting studies that I wanted to share with you. My name is Dr. Mikhail Rashik of Neurogenomics. Let's get going. So what did these guys do? They investigated something like almost 1,200 FDA approved medications, so quite a bit. By the way, I apologize for the hair because I was swimming in the sea. Oh well, let's keep going anyway. And they contrasted that with against antibiotics. So we know that antibiotics can affect our microbiome, our gut bacteria, right? We know this, and that can in fact sometimes weaken a person's immune system to the point that you might have a risk of having opportunistic infections as a consequence of that afterwards, just because of the radical impact that antibiotics can have on the gut microbiome. But what about any other drugs? So I'm going to share with you this one figure that these guys showed, my favorite figure of the paper, and let me break it down for you. So in this figure, you see a lot of dots. You see blue and red points. There's circles and triangles. They represent both gram-positive and gram-negative bacteria. Let's ignore that. Let's focus on the color. Blue ones refer to commensal bacteria. So those are the part of your microbiome that works symbiotically with you to make sure your gut is working well. So those are commensals, okay? And they investigated 47 different types of these bacteria. So individually, they investigate them against either certain antibiotics or those 1,200 FDA approved drugs. And they also investigated 5 pathogenic bacteria. So these are the type of bacteria that can cause issues in your gut if they start growing too much. So your gut microbiome is supposed to normally protect you against such issues by either competing for food resources, by influencing your immune system, and also potentially by making sure that they just have no capacity to grow. Some of the right bacteria can keep the negative bacteria or the pathogenic bacteria in check. All right. So they check all of these different type of bacteria individually by my antibiotics and these drugs. So let's focus on antibiotics first. And actually, before I go there, if you look at this diagram, really what it shows you, if you look at the very left-hand corner, it would mean that those are the bacteria, your gut bacteria, that are influenced by the least number of either antibiotics or medical non-antibiotic drugs, so drugs that don't affect bacteria normally. And if you look at the top right-hand corner, that would indicate those are the bacteria in your gut that are affected by the most antibiotics as well as most FDA-approved drugs. So now let's focus on the antibiotic drugs, and those are represented by the y-axis. And you can see that all of these 47 commensal bacteria, as well as these 5 pathogenic bacteria that they tested, they fell into place where they were affected by about 50 to 90 different antibiotics in that range. But if you were to take the mean of it, so it's not an average, mean is where you see them most often in the middle being affected by antibiotics. The point here is that both the commensal bacteria as well as the pathogenic bacteria, they were affected by equal amount or an equal number of different antibiotics, around 80. And you can see that on the very, very right hand side of this diagram. You see these plotted by these little squares. The line inside those squares show you the mean, and it shows you that it's about 80. And above these 2 squares, you see the letters NS, and that tells you that this is non-significant. There's non-statistical significance observed between the commensal bacteria as well as the pathogenic bacteria. So the point here is that antibiotics, when you take antibiotics, they affect both the good bacteria and the bad bacteria equally, okay? But now let's take a look at the FDA approved drugs that are not antibacterial. These are just for a variety of different conditions. So they tested drugs for many different things. And here you see a range from around 10 to about 100 amongst all the different bacteria. And you can see that when it comes to the commensal bacteria, the ones that are good in our gut, the ones that we want to work well in our gut, it ranged all the way in between that. And if you took a mean of that, the mean was about 53. But if you now look at the pathogenic bacteria, the ones shown in orange, then you can see the mean was much lower. There you can see they are much clustered on a left-hand side, and their mean was about maybe 17. So big difference. And the take-home message here is that the regular medications affect commensal, the bacteria, the good bacteria, much more than they affect the pathogenic bacteria. And really the authors mention is that what it means is that the commensal bacteria, the good guys, they don't have the same means of dealing or getting rid of the drugs the same way, or the impact of drugs the same way that pathogenic bacteria do. So that's the finding number one, that regular drugs can affect our microbiome a lot more, the commensal bacteria, than the pathogenic ones. All right, so but these guys didn't stop there. They also did a couple more very cool experiments. And one thing they did is they created a community of these bacteria. So far, everything I've told you about, they tested it one by one. So each bacteria, they individually tested it for... each bacteria was individually tested by all of these different drugs or antibiotics. And now they created a community of about 20 of them. And they took that community of 20, and what they did is they spiked it then with one of these pathogenic bacteria. They focused on Salmonella. So we all know about Salmonella. Salmonella is this foodborne pathogen that can, well, if you get sick from it, you'll have bad diarrhea, right? So we all heard about Salmonella. And they were seeing, they wanted to see what happens if you spike it with Salmonella. And this community of 20 commensal bacteria resisted the ability, they prevented the Salmonella from being able to take over and grow. So they resisted the Salmonella takeover in that community. And then what they did is they tested one of those 53 drugs that were affecting the community that they observed before, one by one. And they wanted to see what do these drugs do to the community and what kind of impact that will have on Salmonella growth. And they found 17 drugs that had an impact and affected the Salmonella growth afterwards. And 2 of them, once the drug was given to the community of 20 commensal bacteria, they prevented the Salmonella growth, but 15 of these drugs actually promoted the Salmonella growth. So it shows you that certain of these medications, you might think you might be taking these medications, and these medications, one of them was antipsychotic, one of them was antihistamine, one of them was for fertility issues. So wide range of these drugs can affect the community of your microbiome to a point that Salmonella could take over. And they tested a variety of different things. They were able to see which specific bacteria and community you could remove and you would prevent Salmonella growth, for example. So but the take-home message that they observed is that what these drugs did is they started to affect the diversity of this community, and the lower the diversity of the bacterial community, the more likely that Salmonella growth could occur afterwards. They also tested that in mice. So they wanted to show, hey, if this happens in a petri dish, everything I told you so far, they were looking at in a laboratory test. So that's called in vitro. So they also wanted to test in a living organism, and that's called in vivo, and they tested the mice organism. They used mice that were devoid, I believe, of microbiome, and they were able to seed it with that community of that 20 commensobacteria that they were testing. These are human commensobacteria. They were able to seed those mice, and they were able to replicate these observations that when they gave mice a drug and afterwards they introduced salmonella, they to these mice, they fed, basically they would provide salmonella to these mice, then these drugs would affect the ability for these mice to either resist the salmonella growth afterwards or not. And once again, the same drugs that they were able to show in petri dish that promoted salmonella growth, they were able to show that all over again in mice. So the idea here is that very likely this is something that could be happening with medications with ourselves as well. Now, keep in mind, this is in mice, so we don't know how this works in humans. And obviously, this would be very interesting if this type of experiment was indeed repeated with humans. So, but we don't really know, right? This is the first type of the study of its kind. And I often do these I like these studies that are on new discovery studies, on the fringe, what I call on the fringe studies. I make quite a few videos on these type of topics as well. And I'm starting to look more into microbiome itself as well for a variety of reasons. Most often I've been doing videos in relation to how the SARS-CoV-2 virus might affect the microbiome or how microbiome might be protecting you from SARS-CoV-2 infection. But I've done other videos related to microbiome as well. One more example that I'll give you, I did a paper on how ivermectin might be affecting microbiome, but that paper was retracted, which is the first time I've ever seen a paper being retracted for proposing a hypothesis, which is crazy. But this was also in a crazy times. This was during the pandemic that was published, and during the pandemic we lived in psychotic times where scientific censorship was just absolutely nuts. So maybe this is why this happened. So I'm obviously starting to look more and more into microbiome, and this I thought was really, really interesting. But keep in mind, what they were observing is not necessarily what would be found in humans, and we clearly need to see what medications would do in humans. Nevertheless, the take-home message is clearly, if one can avoid taking drugs, that's the best. I'm not saying don't ever take drugs. What I'm saying is the best thing is to stay as healthy as possible, to avoid taking drugs for as long as possible in your life, because while you might be taking a drug for something that you're trying to help your situation in one way, it might be causing a problem in another way by dysregulating your microbiome and allowing your microbiome then to be taken over by pathogenic bacteria. So the take-home message is, try to lead as healthy lifestyle as possible in order to avoid seeing doctors as much as possible and taking drugs for as long as possible, while I recognize it's unavoidable over time, and eventually we all have to take some drugs for some things that will be broken down in our body. All right, that's all I have for you in this video. What I'm gonna mention is also, please give a like, please share, please leave a comment. This is how we grow. YouTube really loves this. You know this, I know this, everyone knows this. But also, please check out my Patreon account. All of the videos I make are, almost all of the videos I make are typically pre-screened on the Patreon account first, and then my supporting patrons decide what gets to be released on YouTube as well. And there's other perks as well. You do not have to be supporting member in order to enjoy the patrons. There's other free content there as well. And I'll see you guys next time. Bye everyone.